Hey y'all, this is a quick video on number 1, identifying if a relationship is proportional, number 2, identifying the constant of proportionality if it is, and number 3, writing an equation for that relationship. So we're going to start with tables. You can see here this first table, I have circled X and Y partners in different colors, and I have figured out what Y divided by X is for each of those X and Y partners. In this case, every time we do y divided by x, you get 2. What that tells us is, first, this is a proportional relationship. The ratio of y over x is the same for every pair of numbers. It also tells us that the relationship between x and y is the number 2 tells us. Any x I can multiply by 2 to get to y. So our equation for this table would be y equals 2x. I could then find the y value for any x value in the world. Looking at this table over here, I have 6 and 2 for my y and x partner, and their ratio simplifies to 3. Down here, I have 21 and 6 as my y and x, and that ratio simplifies to 3.5, or 7 over 2. Since these two values are not the same, this is not a proportional relationship. I am not going to be able to write an equation the same way I did for the first one. All right, here we're going to look at a couple graphs and look at what makes it proportional versus not proportional. So you can see here I've labeled my ordered pairs as I go up this line: 114, 228, 342, and 456. And I simply did y divided by x, just like I did on the table. And every single time along this line, I got 14. 14 divided by 1, 28 divided by 2, 42 divided by 3, and 56 divided by 4 is always 14. Since the constant of proportionality was the same for every point, I know that this is a proportional relationship. I know that for any x value, I can multiply by 14 to find the y value. 2 times 14 is 28. 3 times 14 is 42. So my equation could be written as y equals 14x, or 14 times x. Whereas when we look at this graph over here, I know I have a point at 224. So when I do y divided by x, I get 24 divided by 2. That's 12. So the constant proportionality here is 12. Up here, I've got a point at 6, 32. When I do 32 divided by 6, I get 5 and 1/3. That is a different number. It is not the same constant of proportionality. So this is not a proportional relationship, and I cannot write an equation the same way that I did for this graph. A notable difference between proportional relationships and non-proportional relationships is the graph of a proportional relationship will always be a straight line, and it will always go through the origin 0, 0. Last, we have looking at equations. You may have noticed that when we wrote the equation for the table and the graph, it was in the format of y equals k times x. And we talked about this in class. If it is in the format of something times x, it is proportional. That is a proportional relationship. I can take any value of x and multiply it 1/3 to find my y value. Over here, we have y equals 4x minus 8. Because we are adding or subtracting, it is no longer proportional. We also mentioned in class when we have an exponent. So for example, y equals x to the 3rd power. That would not graph as a straight line. That would not be a proportional relationship. Only y equals k times x. To find our constant proportionality, you just locate the number that is being multiplied by x.